Hi, this is Stephen Brower from Mountain Valley Community College. This is take number 3. um, this is part 1 of Booth's algorithms for Stallings, chapter 10. I'm reluctant to show the slides from the publisher, but if you do have the slides for the publisher in front of you, scroll down till you find the flow chart that accompanies Booth's algorithm. And then the slide after the flowchart for Booth's algorithm, there is a table that the author has created. And then the slide after that is this slide right here, which is something that I created. So what this example is showing is the multiplication of 3. Hang on a second. Sorry. This is showing the multiplication of 3 times 7. And so we're using binary for this. So this is the binary representation of 3. This is the binary representation of 7. For simplicity, this example is only dealing with 4 bits. And as a signed number, 4 bits, meaning the largest number we can have, positive, would be 0, 1, 1, 1. So 7 is the largest number that we can have. In this algorithm, we begin with the initialization. And so the initialization is this A is going to be all zeros, 0, 0, 0, 0. Q is going to be one of the operands. So here we're using 3 as one of the operands. Q minus 1 is going to be 0. And then M is going to be the other operand. Now, what the algorithm will consist of is for each of the steps, and so 4 bits, there's 4 steps, 6 bits, there's 6 steps, 32 bits, there's going to be 32 steps. And what each step will do is it'll look at Q0 and Q minus 1. So it'll look at this bit, which here this is a 1, and this bit, which is a 0. Based on those pair of bits, there's 3 different possibilities that would be done. One is we subtract M from A. Remember, this is A. One is we subtract M from A. The other one is we add M to A. And the other thing is we don't actually add anything. And all 3 of them, when we're done, we do a shift. And one of the slides on the publisher slides shows, remember how like doing multiplication, long multiplication, you would have these series of products and you would add those products together. And so part of the shifting then is doing the adding of the products. So in this particular example right here, though, this first line here, this is the initialization. So our A is 0, our Q is 3, our Q minus 1 is 0, and our M is 7. So then we look at these 2 bits, 1, 0, and 1, 0 says the first thing we do is we subtract M. Well, instead of subtracting M, we can add a negative M. So if this is M, 0, 1, 1, 1, to come up with the complement for it, we flip the bits. So 1, 0, 0, 0, add 1, 1, 0, 0, 1. That is the 2's complement of 7. So that's basically negative 7. And for any doubting Thomases, if you were to take 0, 1, 1, 1 and add to it 1, 0, 0, 1, you would end up with 4 zeros, 0, 0, 0, 0. So the subtracting M, here is the minus M that's being added to A. And so 0 and 1 is 1, 0 and 0, 0, 0 and 0, 0, 0 and 1 is 1. The next thing that's going to be done is a shift. But to make the shift a little bit easier, I'm just going to right now copy these bits down. So these bits are copied down, and now we're ready to do the shift. So the idea of this shift is everything within A and Q shifts 1 bit to the right. So Q0 shifts to Q minus 1. And then this bit shifts here, 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 this bit shifts here. And what happens is this last bit here is kind of like left over. And so what we do is we make a copy on whatever this bit is. And by making the copy, we're maintaining the sign of what that product is at that particular moment. So this right here is the result of the shift. And by the way, if you notice, M never changes throughout this algorithm. That completes step 1. So now for step 2, we look at, in this case here, the 1, 1. 1, 1, all we do is a shift. Well, this here, I just made a copy of what the bits are. We're about to do the shift, just because it's easier to see the shift within here. So this is just a copy of these numbers here. So then the 1 shifts here to the right. This 0 shifts here, 0 shifts here, 1 shifts here, 0 shifts here, 0 shifts here, 1 shifts here, 1 shifts here, and then we make a copy of this 1 for filling in this 1 here. And so this is the result then of step 2. We look again at these 2 bits, so Q0 and Q minus 1, and we have 0, 1. So 0, 1, we add M to A. So remember, this is our A. We add to it M. Remember, our M was our 0, 1, 1, 1. So 0 and 1 is 1. 1 and 1 is 0. Carry the 1. 1 and 1 and 1 is 1. Carry the 1. So 1 and 1 and 0 is 0, but we don't have the carry. These bits here, I'm just going to copy over for the shift. And then for the shift, the 0 comes to here, 0 comes to here, 1 comes to here, 0 comes to here, 1 comes to here, 0 comes to here, 1 comes to here, 0 comes to here, and so then we make a copy of this 0. We make a copy of it here. So now we look at, so for about to begin step 4, we look at these 2 bits, Q0 and Q minus 1, 0, 0, well, it's just to do a shift. So this right here is just a copy of the numbers that are here, and then the shift. 0 goes to here, 1 goes to here, 0 goes to here, 1 goes to here, 0 goes to here, 1 goes to here, 0, 0, and then we make a copy of the 0. So the result then, I'll switch back to the pen for a second, these 8 bits, remember we were doing 4-bit multiplication? Well, 4 bits times 4 bits, we have 8 bits. And so these 8 bits represent the result of our multiplication, and this is the value 21. 3 times 7 is 21. To kind of draw a parallel then to what we're going to have, this isn't exactly right, but think of it this way. Imagine if EDX is the upper bits and EAX is the lower bits. So if we were doing 32-bit multiplication, we would have the lower 32 bits would be in EAX, the upper 32 bits would be in EDX. And so I'm just trying to correlate, and not exactly precisely, but it kind of how that is of what's happening behind the scenes in terms of the processor. This is only showing 4 bits, but then 32 bits is on a larger scale. So the part 1, there's going to be another video that follows this that I'm going to redo this same chart, but using -3. So -3 times 7 will end up with here a -21. So that will be another video.